Hello, students, and welcome to Flintastic Chemistry. I'm Mr. Flynn. Today, we're going to be talking about radioactivity and transmutation. This will be the beginning of a video series about nuclear processes. All right, so we're going to be on chapter 17. All right, it's next to a picture of a Mars rover. Okay. All right, so this is it's in the second volume. So if you flip the book over, it's volume 2. It's got an orange heading, and it's a little bit thicker than the other book, and it's got lots of information. So as you go through this chapter, please know that I'm only doing parts of the chapter. There's a lot of information here, and we just don't have the time to cover it all. And it's not really in our standards, so we don't necessarily have to dive into those things unless maybe you're interested. Maybe you can get some feedback. If you're looking through the chapter and something you want to know more about it, come talk to me and we can see what we can do. Okay, if you have questions, I'll be here to help answer those as you're reading through the chapter, but please know we are not going through the whole chapter. We are only taking bits and pieces as we go, okay? All right, so first off, let's record. I want you to write down these two definitions into your notes. We have transmutation and radioactivity. All right, so if you need to pause the video or if you have a book, I want you to write these vocabulary words down, okay? All right, let's get started. So at the beginning of the video, there was a video of gold bars. The reason I put that video in was because when I hear the word transmutation, it reminds me of that ancient study of alchemy. If you've never heard of alchemy, you may want to go look it up. But basically, scientists and chemists were taking pretty ordinary materials like lead, copper, iron, and they were trying to turn it into something valuable or extraordinary, like gold, something that had value. And they were trying to take these ordinary things and change them, right? In today's chemistry, that's actually possible. They failed, but we're capable of doing this. And if you look here, gold is located right here in this middle of this transition metals, the D block of the periodic table of the transition metals. And right next to it, we have mercury. There's a isotope of mercury that's very rare, okay? It's not very common. It's less than 1%. And we can take that and we can do a process called electron capture, and we can actually turn it into pure gold. And gold is relatively stable. It's got a great shelf life. It's not going to be falling apart or turning into other elements, okay? While you may have heard of elements like uranium or thorium in the news, because those are elements that are used in reactors in nuclear power plants. These elements are relatively unstable, and they're going to fall apart and actually turn into different elements, okay? Uranium will actually keep decaying until it becomes lead, right? So we keep this in mind. Elements can change into other elements, and we're going to learn about how elements are formed. Where did they come from? Okay, that's what we're going to talk about in this chapter. So transmutation is when one element can turn into another element, okay? And radioactivity is the process by which nuclei emit particles and rays. There's generally two ways of classifying radiation, and one is through fast-moving subatomic particles, and the other is electromagnetic radiation. And we're going to go through both of those throughout the chapter and break them down and help give us some sense to what those two terms mean of particles and electromagnetic radiation. You may be familiar with electromagnetic radiation because we talked about it earlier in the year, like how atoms can absorb light and then re-release that light, and it creates kind of a fingerprint for atoms, okay? That same electromagnetic radiation is emitted from nuclear decays, but it has a lot higher energy, like in terms of gamma rays, okay? And we'll talk about it more throughout this chapter. All right, and down below here, there's an image of a nuclear fuel, right? It's a reactor rod, and these are used in those reactors. And how they work is because they're decaying, right? They're releasing lots of energy, and they're causing water to steam, and those steams turn a turbine, and that actually generates energy. So we actually create energy from atoms that are decaying. And the sun is emitting energy because atoms are being formed, okay? And we're going to go through and talk about all of this, but this is just kind of an introduction to radioactivity and helping understand transmutation, okay? Thanks for watching. Until next time.